Welcome to Ask and Learn.
So in this question, we're given two pulleys A and B. We're given a force of 900 newtons that's exerted on pulley A towards the left. We have the radius of both pulleys to be the same, to be 60 millimeters or 0.06 meters. We have the coefficient of static friction of both of the pulleys to be the same, to be 0.35. And we have the angles between the belt and the pulley for both of these systems to be the same, and that's 180 degrees or pi radians. And we're asked to calculate the maximum tension T2 as well as the moments, the largest couple that can be exerted. So to solve this question, let's first assume that we have a force T2 this way and the force T1 exerted on pulley A. And let's use that to calculate T2 as well as M. So if we look at pulley A, we'll see that there's three forces, T2, T1, and 900 newtons. So let's use the equation where the sum of the forces is in equilibrium to get our first equation. So we have T2 plus T1 minus 900 newtons is equals to 0. So that's our first equation. Now for our second equation, we can use impending slip on A. So since both A and B have the same angle and the same static coefficient of friction, we can just look at the impending slip on pulley A. So for impending slip, we have T2 or T1 is equals to E to the static coefficient of friction times the angle pi. And that's our second equation. So now we have two simultaneous equations, 1 and 2, and we can use that to calculate T1 and T2, and then use that to calculate the moment. So first we'll be solving part B of this question, and then we'll be solving part A. So from equation 2, we have T2 to be equals to 3.003 T1, and we substitute that back into equation 1 to get 3.003 T1 plus T1 minus 900 is equals to 0. So 4.003 T1 is equals to 900, and therefore T1 is equals to 224.83 newtons. So we have T1 here to be 224.83. Now let's calculate T2. So T2 is equals to 900 newtons minus T1, which is equals to 675 newtons. So T2, which is equals to T max, is equals to 675 newtons. And that's our answer to part B. So now let's go back to part A, where we're asked for the moments. So going back to this diagram, we have T2 to be 675 and T1 to be 224.83. And let's use that to calculate the moment of A using our radius. So we have the moment of A to be equal to the difference in tension, T2 minus T1 times R. That's equals to 675 minus 224.83 times 0.06 meters. This is in newtons. And that's equals to 27 Newton meters. So our answer to part A is 27 Newton meters, and our answer to part B is 675. Oops. Yep. 675 newtons. And this is our answer.